evaluates the true only if one of the arguments are true. Oh, sorry, there's one more. Not. I haven't talked about not. So not, it's the more obvious. Not is just not true is false, not false is true. If I say you're not fat, well, it means you're skinny. Like, it's the opposite. If I say 2 plus 2 does not equal 3, that statement is true, because 2 plus 2 does not equal 3. Not is just not takes in true, and it outputs false. Or not takes in false, and it outputs true. It just negates. It negates whatever you inputted. Okay? So, yeah.
So there now would be one argument.
Yeah, so the question was, so and or, you can have several arguments. You can have and, argument 1, argument 2, argument 3, argument 4, and so on and so forth. And same with or. With or, you can have argument 1, argument 2, so on and so forth. With not, you can only have one argument. Okay? So with that being said, what's the contract for not? We should all be able to think about what the contract for not is right now. So not, what does it take in? Yell it out. What does not take in?
Boolean.
A Boolean. And what does it produce?
Boolean.
A Boolean. It takes in true and it produces false. Or it takes in false and it produces true. And just to show you what I mean by that, so if I had the racket statement not equals 5, 6, what is this going to produce? Because equals 5, 6 produces false. Not false is true. What about and not string less than ABC, DEF? What about this? What does this produce? Yeah? It produces an error. Why does it produce an error? Well, what is this? So string less than ABC and DEF, this evaluates to true, because ABC is less than DEF. Not true is false. However, and requires more than one argument. I can't just say, you're very smart, and you're going to be like, hey, finish the sentence. You know what I mean? You can't just have an and without having a second statement. You always need at least 2 statements for and. So the problem with this is and expects at least 2 arguments, but it found 1. Does that make sense? Now what would this be? And true, true, false, hashtag F. Be false, because there's 1 false in the statement. What about or? True, true, false, hashtag F. It's going to be true, because there's at least 1 true statement there. Okay? Make sense? In second year, you can take a course that goes much more deeply into this is called logic, where you have and or, and you connect different statements together. This branch of math is called logic. I find it pretty interesting, and you can take second year, third year courses that specialize in this kind of math. Yeah?
In bracket, do the and or functions, like, can they take in more than 2 arguments?
Yes, they can take in an arbitrary amount.
Okay.
They have to take in at least 2, but they can take in any amount after that. But it's at least 2. For the reason that, yeah, you can't have a statement that says you're very smart and you need that's not a finished sentence. You need to finish that sentence. In the same way that Dr. Racket, your and argument needs to take in at least 2 things. Okay? Everything's good so far? Make sense? We're good? Okay. Now, same thing as all the other kinds of tracing we've been doing. if you're trying to figure out how to simplify an and or expression, you trace it the same way you trace a regular expression. You start from the left, go to the right, and you go to the innermost expression that can be evaluated, and then you simplify it one step. So if you had a function like where a line that said and, well, greater than string length of str3, and then string equals cat, blah blah. The first thing that would happen is you would simplify the greater than or equal to, you would simplify the string length of str, and then you would simplify the greater than with whatever that length was and 3. Okay, so one more point on this slide I gotta stress, and it's the idea of short circuiting. So the evaluation stops as soon as the value can be determined, and this is called short circuiting. So what is short circuiting? What it means is, if I have a racket expression that has and followed by several true and false values, if it encounters the first false value, it'll stop. So for example, if I do divided by 10 and 0, I get an error. Okay? If I do and divided by 10 and 0 equals 5 and 5, I'll get an error, because it's going to try to do 10 divided by 0, and it's going to give us an error. But watch this. If I do and equals 5, 5 divided by 10 and 0, all I did was I switched the order. Sorry. Let me just do a different example. And divided by 10 and 0, and then equals 5 and 6. Although this would be false, and first looked at the 10 divided by 0, realized that would be an error, and so it said division by 0 not allowed. But if I did and equals 5 and 6, and then divided by 10 and 0, now what's going to happen is it's going to first look at 5 equals 6, and it's going to be like false. And since it encountered a false, it doesn't care what the rest of the things are. And that's what short circuiting is. It's going to look at 5 equals 6, it's going to realize that's false, and then it's going to be like, I don't even care what you have afterwards. I don't care that there's a 10 divided by 0 afterwards. I'm not even going to look at it. I'm just going to output false, because regardless of the other expressions, I already saw a false, and so I know the entire thing's false. So this would actually return false. And the reason this doesn't return an error is because it didn't even look at 10 divided by 0. It just saw false. It said and false something else. It's like that whole thing is false. Because like I said earlier, with and, all of the statements need to be true. So if any one of them are false, the entire thing's false. And that's what short circuiting is. Short circuiting is the idea, once you encounter your first value you need, you don't care about the rest. So how does short circuiting look with OR? Well, with OR stops when we encounter our first true. So we could do OR 10 divided by 0, and then equals 5 and 5, and this gives an error. Because it's going to be like, hey, that's not, you can't divide by 0. But if I do OR equals 5, 5, and divided by 10 and 0, well, 5 equals 5. And so OR is going to be like, hey, I found one true statement. And because I found one true statement, I don't care what you have written afterwards. I have a true statement. And so it's kind of the same way where if you wrote a math test and you got an A, and someone comes to you and they're like, hey, you're really smart, or you're really fat, you're going to be like, oh, well, I found one true statement. Who cares about the other ones? Because you're a smart person, right? Same thing here. 5 equals 5, and since that's true, we don't care about the other statement. And so this will return true. Does that make sense? The short circuiting makes sense. Yeah?
What if you had a value first that was false?
Yeah, so that's a good question.
That and then
So the question is, what if we did like OR 5 and 6, and then divided by 10 and 0? So now, that's actually a really good question. In this case, 5 doesn't equal 6. And because 5 doesn't equal 6, the function's going to be like, hey, we have a false value, so this statement could still potentially be true, because we could still potentially encounter a true value later on. And so, after evaluating 5 does not equal 6, the OR will go on to the next value. And then it'll realize, oh, hey, you can't divide 10 by 0. And so this will return an error. And that's why does it return an error? Because with OR, it'll keep going until a true value. And in this case, 5 didn't equal 6. So it couldn't find a true value, so it just kept going. But in the first example, 5 did equal 5. And so OR found the first true value, and it was like, hey, I found my true value, I don't care about anything else. But here, it was like, I couldn't find that true value, so let's go on to the next statement and see if that's going to be true or not. Okay. All right. One more slide before we call it a day. So this is how you trace and OR functions. So like I already said, if something is, well, let's look at the AND case. So with AND, everything needs to be true. And if anything is false, it's going to stop. So if you have AND false, look at the second one. If you have AND false, followed by some expression, it doesn't matter what that expression is. That's kind of what I showed you when 5 equaled 5 and 10 divided by 0. If 5 equaled 5, it didn't matter that 10 divided by 0 was not allowed. Because 5 equaled 5, the entire thing outputted false. But if you have AND true, followed by some expression, then it has to go to the next one and figure out whether it's true or not. And then lastly, when you have no expressions to evaluate, AND on its own will return true. And the same thing with OR. Actually, we're going into the trace, and so next class we'll actually go in and see how you can trace an AND function and go all the way down to a basic value that's false or true. So that's it for this class. We'll talk about Booleans and then symbols next class. Yeah. So middle of one. So I actually got the one. So don't worry. If you don't get this, it's not that bad.
这个
Very good.
过的话，
But yeah.
就是说这个它是找 false， 这个是找 true。and 是找 false， 或者找 true。不，他找到对的是谁？你说 and 呀？但是不是 short circuit 是它必须得是决定这句全句的到底是 true 还是 false 你才停。你第一个是 and， 它第二个你第一个是 true， 它第二个可能不是 true。
那你用那个当
我试了，就是它必须得全是 true 它才行，或者它找到一个 false 它停了就属于 false。但是我不知道它这是什么意思，就是后面这个是一个 and。
Because it's saying 3 is out of range. And these other areas, it's saying that it can't, there's no third error. Sure, yeah. So the problem is this value right here needs to be changed. So this should be or the string. So what I'm saying is it needs to go to either. I can't do it without really.
他带回去之后让他在国内买呗。我这包子我这包有啥？
calling just and from one function. So when you do call it, it needs 2 arguments. But when we trace it, we go down argument by argument to make sure that if I'm passing it to my grandma, she would understand how to trace that because I show her every
So
step.
regularly,
So in Racket, you can
what I'm doing right now is
if you're actually
I'm gonna
typing
go
up.
zero.
But in tracing,
So
we're going to break it down argument by argument.
Okay? So all this function is doing is
Yeah, so here you have to call it
first and on like
you have to call it with an expression that's going to trigger another one.
like let's just do give the first.
Like, sorry, you have to write it
Because this
with
gives
like
you
2 arguments.
Okay.
So the function and 1 argument and another, or 1 parameter and another.
On like 7. So you
Yep.
because it's past. Okay? So to solve this, rather than going to end, what we're gonna do is we're gonna go to whichever one's minimum. Either
And so
the
because this one's true, we get rid of it,
Event.
and we look at the second
Or
one, and then we find out what the second one does, and then we keep going.
so either go up to the length of the string or to whichever
Yeah,
one.
then we're gonna keep going to just
So let's see what happens.
and then if we get to just and, that means both of ours will be true, which means the whole thing will be true.
We're gonna do
So this is one example,
first
two examples,
and on like
those don't go together, but
and
yes.
say pass the straight. It'll give you the first 3. But
that
now
make
if you do
sense?
first and on hello and you pass it like 10, it'll actually give you only the first 1.
So just
And it's because we're going
and
to
means that when we
we're only going
were,
to the string. Does that make sense? We're not gonna go all the way down.
so just and means that when we were going, if we had and 5 equals 5, 6 equals 6, okay? Then we would go to and true, because 5 does equal 5, true, 6 equals 6.
Yeah, so I
Then
think
we go to
what the time
and,
is
get rid of that
I
true,
think
get
they're
rid of
just
that
happening
false,
on
and then go to 6
grade.
equals 6.
And then
Then and,
your
wait,
whole
what's
time
does 6
grade
equals
is
6?
gonna be
Yes,
all
that's
just
true.
straight.
Then get rid of that true because it worked for us. Now we're down to just and. If we ever get to just and, that means our other 2 were true. So now if we just have and, we're gonna
Right. That one's gonna be tied. It's probably you're gonna have to do it on your own or on the office hours. So since you come in either on office hours, come in the
No,
ISA,
no, sorry.
like that.
So the next line is everything I just told you. So here one second.
Or come to the other. One or the other.
So this is gonna be and true.
But honestly, the first 2 weeks are like much easier. So like it's not that big. Yeah.
And equals 6.
Yeah.
And that should follow our lines, right? And
Yeah.
now Does that make sense? Cool. Perfect. Any other questions? Sure. That just means false. He was just showing you all the different ways you can reach your x. So hashtag f is also false. Good question. Perfect.
Sure, Oh, so I was only talking about the not function. I was talking specifically about, so there's a function called not, and it takes in true, what's false. Yeah, so I was talking about, oh, I was saying not, the contrast for not is which function are you talking about?
Maybe I was a little like.
You probably just think we're gonna
I'm not super familiar with this.
I thought I did.
Because I'm always doing the ones that have last week or last week. So off topic that I can't give you an example of separate.
Right, yeah, no, that's not true. You can have, yeah,
Well,
exactly, you can have,
if there are situations that are separate than something, if maybe it's like how we insert random, like constant, we put the right little body, maybe it doesn't. I'm not actually sure. Do you know an example of top of your head where Dr. Rapid Stepper would do something different than what you in class?
yeah. So, Dr. Racket Stepper, yeah, so I don't actually know the exact.
Yeah, that's what I said too. I was like, I'm not.
But so there are essentially the rules we do in class. Sorry, what steps was this? The rules Dr. Racket does in Stepper, it skips some steps
Yeah.
that we do in class.
So I feel like the situation would kind of be like almost like a high school math teacher versus a university math teacher. Like high school math teacher, when they're like doing a question, they probably show like every single thing, which is what we're gonna get you to do.
Yeah.
But Dr. Rapid Stepper might just like go to a body or something of telling you how to get off.
That's interesting, because on that website, so we're supposed to post
Yep.
stuff. I noticed like several like instances involving concepts where I had to skip like 6 steps at a time.
Yeah.
You probably weren't actually skipping steps. You probably thought you were, but you weren't. So for example, when you plugged in, when you had f, y, x,
Yeah.
and you had to automatically plug in
Like a constant.
9 and 3 in like the body, that wasn't skipping steps.
So like I had like for example, I had a constant that was like a huge super long thing like divide plus
Yes.
like,
Yeah.
and thing.
Yeah.
And first of all, instead of evaluating that constant to what it actually was,
Yep.
and like having calculus and stuff, I had to in a single step evaluate the constant to what it was and do all the operations
really?
within the constant
Yeah.
to evaluate it down to a single value. And that was all
Because you
within
can
the
put
step.
in constants right away. So that is one of our trace factors. When you evaluate a constant, if it has like a value, you just put the value. You don't have to put in the body of the constant. You don't have to put body of the constant.
Even if like the body of the constant has other variables that are dependent on other things.
As long as they're dependent on their constants. So I actually didn't show any examples where like we plugged in constants as like a trace. I didn't show you that, but like yeah. So if ever you have constants, you just assume, as long as they're not evaluated to like a function. Like if you have define x as like function of 5, that's not going to be. You need to simplify that. But like if you have define x as like y times y, and y is another constant, y is defined as like that times 5, and that's another constant.
Yeah.
That'll
And you can do it all at once.
It's all in one step.
yeah. And I just think that I didn't show any examples of that. So that's why like that point was there.
So like single step constants are always evaluated until they can't be evaluated anymore.
Yeah, so until you reach like a function,
Yeah.
and evaluate. So as long as the constants are just being evaluated based on other constants, you're still good to keep going until you get a function.
When you say function, stuff like the plus function, divide function.
Oh, sorry, self-defined functions, like f of something.
Okay.
Good clarification, yeah.
Yeah.
Not like basic math built-in functions, you
Not
can just
built-in
do those. But like self-user-defined functions, then you have to stop because then you have to explain, this is how you use my user-defined function. You can see but we don't have to use like plus.
And that's the same for both what we do in class and Stepper.
Like, what does Dr. Racket Stepper do for that?
Does Dr. Racket
Dr.
also-
Racket, it's a little bit different than what we do in
I'm
class.
not sure what Dr. Racket Stepper does. To be honest, it might be like just more confusing to try to figure out what Dr. Racket Stepper does because you might then get like on a test and then forget which ones but
In general, don't use like Dr. Racket Stepper unless you're really confused as to
yeah,
exactly.
Dr. Racket Stepper is like a great tool to debug your thing, like to try to figure out, oh, okay, like where is it maybe going wrong? but it's not a good tool if we're asking you for a trace. Don't put it in Dr. F separate, just hit next and write what it gives you because you might not get it right based on what we've asked you. Yeah.
Good to know.
Sweet, good questions.
Thank you.
No problem.
And I like the question you asked in class too. Like most people don't participate enough, but like you actually ask like good questions. So like thank you for that.
I don't think I'm gonna ask too many questions.
No. You're also super helpful. I remember, obviously, I think your lab is Thursday night, right?
Yes.
Yeah, I was helping with one. It's not normally my lab time, and I was like helping with something, and some guy gave an answer, and I like didn't know whether it was right or not. And you were like, oh, I think he is correct, but this is why it works. And I was like,
Thank you.
perfect. Yeah, you did. It was wonderful.
I guess I forgot.
Well, thank you for it because I didn't know what I was trying to figure it out on Racket, and then it was like right, and I was like, shoot, I can't give a reason why it's right. You were like, oh, it's right because of this, and I was like, yes, it is. Great job. So thank you. We appreciate it.
Yeah.
Cool. Welcome, I guess.
Have a great day.
See you too.
That was good. I think it went well. I think I spent a little longer than I wanted to leave.
I mean, they're helpful.
Yeah, I think they're pretty useful.
Yeah.
Good. Awesome.
Yeah, I just wanted to comment in case sometimes people see prop examples and they're like, oh, I have to copy this like word for word exactly what it looks like in
Right,
my
right.
exact space. So I just want to make a note in case people were looking at their notes, being like, oh, you did that. And I was like, yeah, I did. It was on the wrong tab, but like,
Right,
don't
right,
confuse. Because I
right.
heard someone go, implementation. Is that one of our things? And I was like,
Right.
no, it's not. But like, it's right. But you don't.
Right, right, right. I actually think I saw it on it. So I usually don't put it. I saw it on the slides, and like that's why I did it.
Implementation.
But no, it's not. It's not. Like it's not part of it.
Okay, I was like,
It's not.
oh shoot. I was like, I haven't seen that, but no. No worries.
Yeah, I well, I think a lot of why I started putting it because I saw it in the slides, but like it's actually not a part of the user.
Yeah.
It's not a thing.
Hopefully that's not a change that now they're supposed to comment implementation.
Yeah.
Anyway, cool.
Alright, awesome.
Okay, sweet.
Yeah.
See you.
Alright,
Tuesday.
I'll hold I can do grades now, so
Okay.
yeah.
No worries. I will see you Thursday.
Yeah, see you then.
Oh, don't forget your phone too.
Oh shit. I almost forgot it last time too.